Hello, hello, everyone. This is so cool to see everybody's here. A lot of people are here, 14 people. Okay. Can you guys hear me? Can see me fine? How are you guys doing? Okay. Yes, you can hear. Okay, cool. Perfect. Good. I'm doing good. I am ready to teach you guys some chemistry. You guys ready to learn? Now, leaving the chat, are you ready to get that A? So not just pass now, to get that A. Yes, Megan says. All right. All right, guys. So at any point, if you have a specific question, you can look and see that to ask a question button, and then I will be answering those questions towards the end. Right now, what I'm going to be focusing on is significant figures, unit conversions, and density. All right, so I'm going to go ahead and start. Let me move this. Let me go back. There we go. All right. So starting with those pesky sig figs, everyone's favorite, right? Not mine. Let's just go over the rules real quick once again. So just remembering our sig fig rules. How many people remember sig fig rules? Yes? I hope so. All right, so the ones that we for sure have to know are the ones that are not significant. Remembering that any leading or beginning zeros, so by leading or beginning, remember that was the 0.00583, and we know that these three leading zeros do not count as significant. So in our case, we're only going to have 3 sig figs. We all remember these rules? I'm sure we saw my first video. So that was one that we for sure had to know. The next one was any zeros in a large number without a decimal are not significant. So in this case, if we were to have, let's say, 5,000, since there is no decimal, just that 5 counts as a significant figure. So these zeros do not count. Now, I am getting a lot of questions before where, let's say, if we had our final answer being only rounded to 1 sig fig. And let's say our final answer was that 6,000. A lot of times students think that we're just going to round to just say 6. We can't just get rid of those zeros because that changes the value altogether of the number, right? Think about it as in terms of $6 versus $6,000, right? Totally different. Okay. Everyone okay on this concept? Yes. Yes. Cool. Okay. Just wanted to see where we're at. And then we remember all the specifics. So in this case, at this point, I'm going to have us actually try them out. So looking at A, that first one, what's our answer? How many sig figs do we have? 1. Good. Because that then is good. Everyone's getting it right. Perfect. We know that just because leading zeros do not count, only that 4 counts. There's only 1 sig fig. All right. What about B? Mm-hmm. Good. Everyone's fine with sig figs, it seems like. Just 1. Beautiful. All right. You know what I'm going to ask next? What about C? Good. So C was, all right. So I'm going to go back to B real quick. I saw an answer. So going back to B real quick, none of these zeros count because it's a large number without a decimal. So only that 4 counts as 1 sig fig. So that's why we're not going to count all of those zeros as significant. And then for part C, every single one of these digits is significant because any zeros after the decimal are significant. So in our case, we're actually going to have 3 sig figs. Okay. Let's move on to D. What do you guys say? 3, beautiful. Yes, every single one of those is significant. Good. All right, moving on to E. How many sig figs in part E? 2. Good. 2. Any coefficients or zeros in scientific notation are significant. Good. So there's only 2. And our last one, just to see where we're at. How about F? 4. Beautiful. Those zeros sandwiched in between are significant. So we have 4 sig figs. Okay. We seem to be okay with that, which I am so happy about. So I'm going to move on to, oh, am I not able to see that? Here, I might have to write these out. I'm going to move on to adding and subtracting, dividing, and I know that that tends to be a problem. So let's say if we had 7.28 minus 2.104. So remember our rule, whenever we're adding or subtracting two numbers with different significant figures, we look at, anybody remember when adding and subtracting, what do we look at? Anyone remember the rule? The decimal places, beautiful. We look at the least amount of decimal places. So looking at 7.28, there are only 2 numbers after that decimal, so there are 2 decimal places. Versus our other number, which there are 3 numbers after that decimal, so there are 3 decimal places. So we will only be rounding to the least amount of decimal places, so we're rounding to 2 decimal places. Okay. Moving on from this, you want to subtract these first, and then we'll round at the very end to 2 decimal places. When we punch this into our calculator, 7.28 minus 2.104, you get 5.176. So we're going to round to 2 decimal places, so we'll stop here and round up. Our final answer is 5.18. Everyone good with this? Any questions? No, we're good. Cool. Beautiful. I'm going to move on. Okay. So moving on, I'm going to go to multiplication and division. Don't worry, I'm going to have plenty of conversion questions. And then, like I mentioned, towards the end, I'm going to be answering all the other questions. So at any point, if you have a specific question, ask a question for those of us just joining in. All right. So let's move on to something like 32.27 times 1.54. So now we are multiplying. So with multiplying and dividing, what's our rule with significant figures? What's the rule? You guys remember? When multiplying or dividing, what's the rule for significant figures? Anybody? Smallest number of significant figures. Good. Good, good. Cool. Okay. So we'll start with this 32.27. And remember that any non-zero number counts as significant. So we have 4 sig figs in this case. Same goes for this one. We see that all of these are non-zero numbers. However, we have 3 sig figs. So we're going to round to only 3 significant figures. All right. So after we multiply, so punch that into our calculator. You get 49.6958. But we're going to round to 3 sig figs. So we'll stop right here at that 6, giving you 49.7. Now, I was asked, what do you do when you have addition and multiplication put together? I was going to answer that question right now. a lot of this goes back to math. And I'm sure you guys remember, I hope you guys remember PEMDAS, or order of operations. So I'll put that here, PEMDAS. Little bit of a math review. We know chemistry has a good chunk of math. Everyone's favorite, right? So let me start answering. Let's see. Whose question was this? Angel. So Angel's question was, can you do a problem with both adding or subtracting and multiplying and dividing with significant figures? And I'm answering that right now. All right. So with this type of question, let's say if we were given, let's say 1.750 times 0.0342. And we're also adding 16.05. So I'm going to go back to PEMDAS, or order of operations. And remember, this was parentheses first, then exponents, then multiplication, division, and then addition and subtraction. So in our case, the first thing that we see is multiplication. So we need to treat multiplication. We need to do multiplication first. And then after that, we're going to add. So I still want you to think of the rules for significant figures when it comes to multiplication. So I'll start there. Multiplication, we said we want the least amount of sig figs. So in our case, we have 1, 2, 3, 4 sig figs in this first number. In our second number, remember these two leading zeros do not count. So I only count these 3 at the end. So we have 3 sig figs. We'll multiply and round to 3 significant figures. So let's see what that gives us. 1.750 times 0.0342. And that gives us 0.05985. We'll round to 3 sig figs. So stopping at, this is 1, 2, 3 sig figs. We round up because of the 5. You get 0.0599. But we're going to continue on. So I'm going to bring down that adding 16.05. And now, as we add, we look at the least amount of decimal places. So looking at our least amount of decimal places, for this first one, we have 4 decimal places. All right, 4 decimal places. Rather, for 16.05, we only have 2. So we're going to round to 2 decimal places after we add. That's 16.05. That gives us 16.10985, round to 2 decimal places. So we will stop right here, round up because of that 9, and your final answer is 16.11. Did I lose anybody? This is making sense. Questions? Everyone get it? Yes, yes. Cool. Cool. All right, everyone's getting it. Beautiful. So I'm going to move on to those pesky unit conversions. Everyone's favorite, right? Okay. My struggle. Yes, struggle is real. Do people still say that? I don't know. Okay. So everyone's favorite, I know. All right, but hopefully after this, you will be walking away confident knowing how to do this. I did want to go over the metric system. So remember me talking about my trick? I wanted to kind of get into more detail of that. I'm not sure if that completely made sense to everybody, but I'm going to do that now. Remembering for the metric system, my trick, please do, yes. My trick was you place that 10 to some sort of exponent with the base unit. And by base unit, I just meant grams, meters, or liters. Another thing is it's one letter. Okay, this will make sense once I put it all together. I can't reset. All right. Next, you place the 1 with our different unit or the one with 2 letters. So what I mean is, let's say if we were going from milliliters to liters. Okay. And if I were to start with, and let's say our given was 3.4 milliliters, and we're trying to convert to liters. So the setup, always start with your given with that 3.4 milliliters. And then we'll place the milliliters across from each other so they can cancel, placing the unit that you want to get to, which is liters, on top. So now that we got that set up, this is where my trick comes in. So I said that you place the 10 to some sort of exponent with the base unit or the one with the 1 letter. So our liters is the one that will have that 10 to some sort of exponent. And the one that we know that actually the exponent that it's going to be is -3 because it's milli. So milli means 10 to the -3rd. Next, the different unit in our case, or the one with 2 letters, is the milliliter. So we'll place the 1 there. Is this making sense? Questions on my trick? No. Wait, hold on. So far, so good. Okay. And the reason why I say this is, I think a lot of you guys know I'm a tutor. So a lot of my students get really confused with this. Like, do you multiply? Do you divide by 1,000? And this is my way to just stop that confusion, and you never have to guess again, which is ideal for an exam. So looking at this will help you stop guessing altogether. So let's try another one. Okay, let's try another one. So let's say if we started with this example, convert 8.900 kilograms to grams. So our given is that 8.900 kilograms. I'm going to place that here. Always start with our given. Align the units across from each other so we can cancel. So I know that kilograms is going to go on the bottom because we'll have to cancel those. And then we're getting to grams, which is on top. All right, going back to the trick. So our base unit, or the one with 1 letter, is the grams. So I'm going to place the 10 to some sort of exponent. And remember that kilo means to the 3rd power. I have the metric system here as well, in case you want to look at that. I also have it in my video, as you guys have probably seen. And now going back to this question, our different unit is kilograms. So that's the one with 2 letters. So I'm going to place a 1 there. And we're done, right? Our kilograms cancel. Now we have our grams, which is what we wanted. Multiply straight across. And your final answer is 8.900 times 10 to the 3rd grams. Okay. How are we doing? Good on this question. Any questions on this first example? Can we do another one? Yes, we can do another one. Here, let me make one up. So let's say if we had, let's do 4.23. Is that the same as 1,000 grams to correct? Yes, it is. Yes, it is. So 10 to the 3rd. Where is my stuff? There we go. 10 to the 3rd, correct. So 10 to the 3rd just means 10 times 10 times 10, or 1,000. Means the same exact thing. Where I'm taking that from, and is just from the metric system, as you notice here. So to explain this a little bit further, all of these numbers go with our base unit. That's where my trick comes from. Where let's say if we're trying to get to, like I just did, going from kilograms to grams, this is where our grams would be linked with, right? That 10 to the some sort of power with our grams. And then this is our different unit, which has that 1. Okay, I'm gonna keep showing that over and over. If it's not making sense now, it will. So continuing with that other example that I was going to do, 4.23, and let's do, why don't we do centimeters to meters? Okay. All right. So continuing with this example, once again, starting with, so grams always falls under 10 to the 3rd power. Only if it's kilo. Here, sorry guys. Let me make sense of this. It depends. So Ruth, it depends on what we're trying to convert to or what we're converting from. So since this was kilograms to grams, our kilo was to the third, but we place it with the base unit of grams. So here, looking at our metric system, kilo was 10 to the third. So we place this 10 to the third with our grams, and then kilogram goes with the 1 unit. Does that make sense, Ruth? Got it. Got it. Cool. These tutorials will be available to see again after we are done. Yes, Diana, they will. Absolutely. There's a replay for everyone to know. There is a replay of this after, so you can re-watch this. All right. All right, guys, I'm going to go back to this question. All right, so 4.23 centimeters to meters. Thank God. All right, Gabby, don't worry. Okay, so 4.23 centimeters, and we're converting to meters. Once again, aligning our centimeters on the bottom and meters on top. We said that our base unit is the one with 1 letter, so our meters is that one in that case, and that's 10 to the, let's see what it is, centi. Here, let me go back. Centi is right here. Right here. 10 to the negative second. So our base unit goes with that, meters. And our different unit is the centimeter. That's where our 1 comes in. All right, see where I'm taking this from. So I'm going to put this back. Bear with me on this, guys. There we go. So meters was 10 to the negative second. Our different unit is the centimeter that has the 1. So right then and there, centimeters cancel. Multiply straight across. This would have been 4.23 times 10 to the negative second meters. And you're done. I'm going to do another one where we have a few more conversion factors, and then I'm going to get into dimensional analysis. All right. So for this example, let's say if we're converting from centimeters to nanometers. Now, there's no possible way for us to just jump to centimeters to nanometers. Instead, we need a bridge to connect both of them, meaning we need some sort of unit that they both equal, which in our case, our base unit is going to be the meters, since they both share meters. All right, so I'm going to set this up. We'll start with our given, which is 406 centimeters. Centimeters will go on the bottom since we're trying to cancel that out. And then I'm going to go to meters. Where did I take that? From this first conversion factor. I went from centimeters to meters. So here, centimeters, those cancel. Now we're at meters. Next, I'm going to use my second conversion factor to get from meters to nanometers. So meters, align that across from one another and put our nanometers on top because we want to solve for how many nanometers there are. So going back to our trick, we said that the meters is our base unit. That's where I take that 10 to the negative second because it's still centi, right? Still taking from this. It's still centi. So 10 to the negative second goes with our base unit, which was meters. Our different unit is then the centimeter, which is 1. Okay, moving on from there, we're at meters and we want to cancel out meters. So our base unit is still, and here, let me show this. So our base unit is still meters. So I'm going to do 10 to some sort of exponent, but now looking at nano. Looking at nano, which is here, that's 10 to the negative 9th. So this is going to go with our meters, and nano is just going to be 1 nanometer. That's our different unit. So this will be 10 to the negative 9th meters for every 1 nanometer. We see that all of our units will cancel except for the nanometers, and we are done. A quick way to actually do this, and I'm going to show the math for 10 to the negative second divided by 10 to the negative 9th. It's a little metric. So looking at this, what you can do is properties of exponents, just meaning that whenever we have the same bases, so 10 and 10, means that we can actually subtract our exponents. So this would have been 10 to the negative second minus, and I'll show that minus, a negative 9. This is going way back to math, where these two would then form a positive. And this really is 10 to the negative second plus 9, which gives us 10 to the positive 7th. That's a math trick. If that is not making sense, plug it into your calculator. Okay, I'd rather you guys be completely 100% certain about it. So on an exam, if you get a calculator, use it. Okay, I say that from experience. Okay, so that being said, I'm just going to plug this into my calculator. Don't worry too much about that math trick. Let's see what our final answer was. Any questions with this example? Nope, none so far. Okay, cool. So centimeters and nanometers contain the meters. Is that true with all the units? Do you have a video on negative numbers? So I'm going to answer Megan's first. So it's not the same for every single unit. Now, Megan, looking at this, we have centimeters and nanometers. Notice that they both share the meters, right? So that's why we were able to say that they equal meters. Same thing goes for, let's say we did kilograms, and let's say we did milligrams. Both of these contain the grams, so those will equal each other. Same thing goes for our other base unit that's possible. Let's say if we had milliliters to, I'm going to say deciliter, they both contain the liters. So that's why we're able to set them equal to each other. For dimensional analysis, which is what we're going to get into next, there are specific units for like length and mass, and we're going to see that in a second. There's no trick to that, unfortunately. I wish. That is really just memorizing. But I will give you a table right now as to what you should know. Okay, does that answer your question, Megan? Okay, cool. Thank you. All right, awesome. Anne, do you have a video on negative numbers? No, I don't right now. Like adding and subtracting, multiplying positive, negative numbers. If you stick around to the end, I could actually answer that question. For now, I'm going to continue on with conversion factors and sig figs. But Anne, if you want, you can go ahead and ask that question and I'll answer that. Okay, cool. All right, guys. So now that we're good with this, here, let me actually give the final answer. I think I might have done this in one of my worksheets, but I'll still put it. All right, so our final answer, I think I actually, hold on, 406, -2, doing this too quick. There we go. Our final answer would have been 4.06 times 10 to the positive 9th nanometers. Okay. Now that we got that down, let's move on to the main event, which is conversion factors. And I'm going to teach this. I'm actually excited about how I'm going to teach this because I really do think it's going to make so much more sense, to the point where you're like, how come I never got this before? And Ruth, real quick. So 9. Yeah, 10 to the negative 9th. When you plug this into your calculator, Ruth, here, let me not erase this all. I know I said it was 7, but it was 406 times 10 to the 7th. Now, if we wanted to actually change this in the proper notation of scientific notation, your decimal is here. That would have been 1, 2. I moved this over twice, so I'm actually adding 2 to my exponent. And that would have been 4.06 times 10 to the 9th. If you plug it into your calculator, specifically plugging it in like this, 406 times 10 to the negative second divided by 1 times 10 to the negative ninth, that will give you the exact answer of 4.06 times 10 to the not negative, positive ninth. Positive ninth. Okay. Got it. All right. Lovely. All right. So let me go back. Erase all this. All right, guys. So I'm going to jump into a dimensional analysis. Really just a fancy word for converting units. I don't know why these chemists really wanted to confuse us, right? But using all these fancy words when you really don't need that. Okay, so starting with this first example of how many minutes will it take a car to travel 857 kilometers if the car is moving at a constant speed of 25 miles per hour? Okay. I'm first going to talk about the setup of conversions, and this, I believe, is going to answer Chris's question. I never know where to start. Yes. And then Erica also has this question. Okay, so I'm going to go ahead and start this. This is how you set it up. So what I always like to do, and I think I always mention this in my videos, saying we always identify our given conversion factors and what we're finding. And why I focus on this is because your given tells you where to start. What you're finding tells you where to end. Your conversion factors tell you the middle chunk. So you really just have to align it. So organizing it every single time actually allows you to just know where to even begin. Okay. So hope that answers Chris's question and Erica's as well. We're going to keep going with this though. And this is why I always do this. Okay. So let me put that at least above here. So this is where we start. This is our middle chunk. And then what we're finding is always what we end with. So that's what I'm going to do now. I'm going to go ahead and identify what our given is, what are we converting, and what we're solving for. Okay. So how many minutes, right then and there, that was the first word. How many minutes? That's what we're finding. We're finding minutes. Next, to take a car to travel 857 kilometers. All right, right then and there, that is our given. Our conversion factor is the one with two different units. So the 25 miles per hour will act as our conversion factor. Miles per hour. Okay. Now, notice that we don't have enough. We don't have enough conversion factors, and I tell you why. If we were to start with our given unit, kilometers, we don't have a conversion factor right now to just jump to miles, hours, and then get to minutes. We need to figure out what's in between. So what I personally like to do is develop a plan. Here is this. All right. I like to develop a plan, and where I start is with the unit of kilometers. Okay. And I'm going to actually erase this conversion factor, and I'm going to put all of the different ones that we have to use. And I'm excited to actually explain this. Let's see. So our plan, kilometers going to something else. So we need to somehow get to miles. And I say this, and how did I know this? Is because our conversion factor said it was 25 miles per hour. I'm going to look at this table and identify what allows me to go to miles from kilometers. And it would have been this one. So that's my first conversion factor. So 1.609 kilometers, I'm running out of space, is equal to 1 mile. All right, so how I knew to also do that. Your first conversion factor is always going to be given units. Everyone heard me on that. I'm going to say it one more time. All right, this is very, very important. So your first conversion factor is always going to equal your given units. That's how you know where to start. So we're pretty much looking to what equals like the next unit. Okay, so looking at our given, we want something to also equal kilometers to be able to allow us to then jump to a totally different unit, which in our case now is miles. So the next thing we want to do is figure out what equals miles to be able to get to a totally different unit. Everyone with me so far? Is that making some sense? Yes, yes. Okay, lovely. Okay. Awesome. So now continuing with this idea, this is where I'm going to put that other conversion factor that was actually given within the question. So this is where I'll have the 25 miles. So notice we have the miles now, right? They equal each other. Equals miles per hour, by the way, is just meaning that there's 1 hour. So 25 miles per hour or 25 miles is equal to 1 hour. Okay. Let me actually show this in a different color. All right, so our miles in this case now equals a totally different unit. And then now we can jump to hours. Now that we can jump to hours, we want something to equal hours and finally give us what we're finding. So we know that 1 hour is equal to how many minutes? 60. And then there we have it. We got what we're finding. So I'm going to go over that again. Cool. Okay. Yay. So exactly. It's like think of it like they're all connecting to each other, right? They're all different pieces to a puzzle, and our puzzle is trying to figure out what the next unit is. So like I said, you start off with what you're given, the given unit. So those kilometers. Then we look for the same exact unit that equals that. So kilometers to connect us with a totally different unit, which was the miles. Now we look at what equals the miles, that 25 miles. Now that we got our miles to equal, we're moving on to a totally different unit, which is the hours. Then our hours will do the same thing. What else equals hours? 1 hour is then equal to minutes. Minutes is what we wanted all together. Let's set it all up. This makes better sense. Love it. Okay. So I'm going to develop the plan real quick, and just to even, I'd rather over-explain than under-explain. That's kind of something I always tell my students. So just to put it all together, our plan, looking at our units, is kilometers. Next, we jump to miles, right? Kilometers, then to miles. And we do this by using the first conversion factor. Next, you go to miles, then to hours, right here, using our second conversion factor. Last, we use our third conversion factor to then get to our desired unit, which was minutes. All right. I'm going to put it all together now. So starting with your given, 857 kilometers. I'm going to put the first conversion factor that we said. But first, I'm going to align my units. So something that I've actually noticed as well is once you figure out what the plan is, it's actually easier to just write out all the units. So like putting it all together and then plugging in the numbers all afterwards. So I like to do that just to kind of help me set it up. So let's see if this helps. So kilometers across from each other. And we said that would then get to our miles, right? So kilometers to miles, that's what I have so far. Our kilometers would then cancel. And then we want our miles to cancel. So we'll place those across from each other. Now we're here getting to hours. We have another conversion factor. And then now we want our hours to cancel to get to minutes, which is what we wanted all along. So I'm going to put everything in between. So our first conversion factor for the kilometers was 1.609 per every 1 mile. And I'll just put that was our first conversion factor. Our second conversion factor, after we see our kilometers cancel and we're now at miles, the miles that we had for our second conversion factor was 25 miles per every 1 hour. Miles cancel. Now we're at our third conversion factor of 1 hour per every 60 minutes. So next thing is to multiply straight across and divide. So what I like to do, just to show you the math behind this, is do 857 times 60, then divided by 1.609 times 25. All right, so I like to do those individually. If you are putting it into your calculator, put a bunch of parentheses, because that tends to be the case with calculators, that they make an error if you don't put enough parentheses. So let's multiply these out. So 857 times 60 divided by 1.609 times 25. And let's see what we get. All right, we end up getting 1,278.309 minutes. And sig figs come back, right? They never leave. They never leave. So where do I look at my sig figs? I'm sure that's something that we're thinking about. You don't look at the conversion factors, okay? Your sig figs come from your given. So since our given in this case is only 3 sig figs, that's what we're going to end with. All right, so that's something to definitely know when we're doing these types of conversion questions. Look at the given, however many sig figs there are, that is how much you're rounding to. So since there's 3 sig figs, I'm going to go ahead and round. And what do? There are actually 4 sig figs here, right? So if you want to do, let's say, less sig figs than you initially have, change this to scientific notation. So scientific notation, we have to take our decimal place and move it to where we have a non-zero number. So our non-zero number would be between that 1 and that 2. So I'm going to move this decimal place over 1, 2, 3. And this really would have been 1.278309 times 10 to the, I said I move this over 3 times, 1, 2, 3. Minutes. However, I'm now going to round to 3 significant figures. So that's going to stop here and round up. And our final answer is 1.28 times 10 to the 3rd minutes. Questions here? That would have been our answer. Thanks. Okay. Cool. All right. So you guys ready to try one on your own? Yes. Possibly. You guys have a pen and paper, calculator? Yep. Okay. Hopefully. Yes. Okay. All right, guys. I am going to let you guys try this one on your own. All right. Now that we learned this, I will be going over it. Don't worry. I'm going to give you some time to just try this on your own. Go for it. Don't worry, I'm still going to give you guys some more time. But just to let you know, don't write the answer. I repeat, do not write the answer into the chat. I'm going to make a poll. So look out for that. I'm going to make that right maybe in like 3 more minutes, 4 more minutes. I'm going to make a poll for you guys to actually click what you thought the answer was. All right, so I'll give you more time. Please do not write that in the chat. I'm done. All right, cool. I was just about to ask that, Anne. Thank you. Does anyone else need more time? I'm gonna add the poll right now. So adding that right now. Start voting what the answer is. I'm good. All right. All right. So I sent out the poll. You guys can vote what your answer was. Okay, we have a couple of not sure's, not a problem. That's what I'm here for. All right, so far, we got some people getting the right answer, other people not sure. Like I said, I will be going over it. Not a problem at all. Okay. So let's go over this question. And like I said before, let's start with identifying our given, conversion factor, and what we're finding. So our given was really the only number that was given, which was 1,454 feet. I'm going to come back to the conversion factor. Next, we're looking for the height in meters. Okay, so if we're trying to get from feet to meters, we're going to need some conversion factors in between. So I left this table here. Now, we need to first connect our first conversion factor, meaning we need something that is going to equal feet, right? So what I'm going to use is actually 1 foot is equal to 12 inches. And I found this right here. Okay. So now that I have feet, I'm now going to go to inches, right? So I got my feet. Now I'm to another unit of inches. So now I want something else to equal inches. And what I have equaling inches is this first one. 1 inch is equal to 2.54 centimeters. Okay, everyone with me so far? Now I have the inches. So inches has to equal something else. That's where I got that 1 inch. Now I'm at centimeters. Next, this is not going to be on this this chart. This is coming back to the metric system. So I didn't want to tie these two together. So since we're going to the metric system now, we're going to use that concept that I mentioned before of 1 centimeter is equal to 10 to the negative second meters. That's how we get to meters. I'll go over that one more time. All right. So I know that this can actually be a little bit tricky because you're not given all the conversion factors. So I just want to show you guys how I figure this out. Okay. So like I mentioned before, we look at our given unit and we want to first use that conversion factor, meaning our given unit must have the same unit pretty much as our conversion factor. So that's why I did feet and feet. And then from there, I'm going to get to inches. Now that I am at a completely different unit, the inches, I also want to set that equal to the next one, inches. And then that gets me to centimeters. My last conversion factor will be the centimeters to meters using the metric system. So that's where that goes hand in hand. Okay, there will be questions that do have both. So I'm going to set this up now. I will do the plan again. Let me erase this. And don't worry, guys, I still have several other conversion factor questions. So this is not the last one. Okay, so just doing that plan, I think it's really helpful. Always starting with our given unit, which is feet. Then looking at our conversion factor, we went from feet to inches. And we used our first conversion factor there. Next, we went from inches to centimeters, and we used our second conversion factor there. Then from centimeters finally to what we want to find, which is meters. That's our third conversion factor. Okay. Questions here. I just want to pause here for a second. For those who said they weren't sure, does this make sense now? The conversion factors, the plan. I'm about to set it up, but is this making sense, guys? Yes, it's making sense, Ruth says. Okay. Okay. Glad it's making some sense now. This is making sense. I was thrown off by the metric portion. Yeah. Okay. I wanted to show it just in case. I went from feet to, Anne says, I went from feet to yards. Same. You guys went from feet to, let's see. There's several different ways to do this, by the way. There really is. Looking at this, inches. Did you guys end up getting the same answer? The ones that went from feet to yards? No. Okay. After I set this one up, hold on. And after I set this up, I'll go ahead and show you the other way that you can do this using feet to yards and then going yards to meters. Okay, let me set this one up and then I'm going to show you a different way. All right, so setting this up. Give myself a little bit more room. So always starting with our given, which was in our case the 1,454 feet. Like I said before, we want to align our feet across from each other. And then we're going to move on to our inches, which is on top. Next, going to inches on the bottom to cancel those out, to centimeters on top. And finally, going from centimeters to meters. So our centimeters will be on the bottom and meters is on top. So I'm going to plug in all the values now. Our first conversion factor was the 1 foot per every 12 inches. Our feet now cancel. We're at inches. 1 inch per every 2.54 centimeters. Our inches now cancel. And then moving on to centimeters, this was the metric system part, where it was 1 centimeter per every 10 to the negative second meters. And that's why, guys, the answer was the 4.432 times 10 to the second meters. Okay. I'll show you a different way. So let's see what we were doing. Cool if I erase this, guys. I don't know if you guys are jotting this down. It's still going to be in the replay. Okay, I think everyone's okay with that. I'm gonna do it over again now using the feet to yards, which we said. So Anne, that's actually part of it. So there aren't 4 feet in 1 yard. There are 3. So there are 3 feet per every 1 yard. I'm still going to go the other way around though. 3 feet per every 1 yard. Let me show that. Oh yeah. So that could have definitely been it. But I'll still show that method. Okay. Here, let me go back. Don't want to erase everything because I have a lot planned for you guys. All right, so let me go back to, let's just go from scratch. All right, so you guys thought to do, we said 3 feet per every 1 yard. So I'll do that here, 3 feet per every 1 yard. So now that we have feet, we're now at yards, and we want to somehow we can actually get to meters now from using our yards, which would have instead been this question. Now, if you guys ask, like, why am I doing it the other way? Now, this is just what I've seen on exams, as well as typically what the units that they actually use on exams or even provide if if you have a nice teacher or professor. But I rarely see professors use 3 feet is equal to 1 yard. I typically see them giving you the inches or you remembering, centimeters and so on. So this table has just come from my years of tutoring and seeing what's on exams. Okay. So, but this definitely is another way that you can do this. So continuing on with this question, looking at the feet, going to yards, I'm going to use that 1.0936 yards is equal to 1 meter. And let me make this prettier. All right. So this one's actually nice. All right. So that wasn't a bad idea for you guys who went from feet to yards and then yards to meters. Looking at this would have been just 2 conversion factors, and we would have gotten our meters portion. So our given, setting this up again, would have been feet on top, then across from each other 3 feet per every 1 yard. And then on the bottom, we'll put our yards to 1 meter. Let's just make sure that does multiply and give us our correct answer. And it does. Let's see, it gives us a tiny bit. No, it does. Yay, okay. 432 times 10 to the second. We know to round to 1, 2, 3, 4 significant figures because your given was 4 sig figs. Okay. Everyone, is this making sense now? That this other way that we also did it. So either way is correct. So as you can tell, there are different ways to solve these conversion factors or puzzles. Okay, so yes, lovely. I'm glad this is all making sense. I'm going to move on to density as a conversion factor, but we're going to keep using conversion factors. Okay, this is just a different way to see it. So can you please show how to plug in on the calculator? Diana, sure, absolutely. So let's see. So what I did, Diana, was I multiplied 1,005, really, we don't have to multiply it by 1. Okay, so that's going to be on top. And then this is divided by, I'm going to put parentheses on the bottom, and I'm going to show that it would have been 3 times 1.0936. So specifically in your calculator, what you can do, depending on what calculator you have, but what I typically do is I put a good amount of parentheses, okay? And I put the 1454 in its own separate parentheses. So as you see, put 1 large parentheses first, okay? Then I'm going to place the 1,454, then divided by, or I should say it this way, and another separate parentheses, 3 times 1.0936. Does that answer your question, Diana? I hope so. Pretty much the main thing is parentheses, parentheses, parentheses. Okay. Calculators tend to make called a syntax error, just meaning they're not sure what you're typing in. Yes, it does. Okay, cool. No problem. All right. Let's go ahead and move on to another question. And let's jump to, here it is. So this is going back to density. Density, as you guys, I don't know if you guys have saw that video, but density, just real quick, we know is mass divided by volume. And I mentioned that density's units tend to be either grams per milliliter or grams per cubic centimeters. And that's what you typically see for density. Now, you're not always going to be solving for density. It depends on what the question's asking. A lot of times you actually use density as a conversion factor. The reason for this is because density, as you see, has two completely different units, and we know conversion factors have two different units. Okay, so in our case, we will be using density as a conversion factor. So let's start from the beginning. Let's find our given conversion factors and what we are finding, as we do every time. So let's read this question. A pure gold bar displaces 0.82 liters of water. What is the mass in kilograms? And it gives us our density of gold is 19.3 grams per cubic centimeter. Okay, so our given in this case is that 0.82 liters. Next, it says what mass, and in this case, it is specifying that it wants it in kilograms. Okay, and our conversion factors, that's something we have to figure out, but we at least know that density for sure is one of them because it gives us two different units. Okay, so we said that our first conversion factor, we want that to equal our given unit. Okay, so our given unit is liters. We want something to equal liters. So there's one thing that I think I stressed in my video, that you have to know 1 milliliter is equal to 1 cubic centimeter. Very, very important. I see this too often. Okay, so knowing that helps, because what I'm going to do, and I'm actually going to develop the plan first just so you guys can see it, is if we went from liters then to milliliters, that would then allow us to get to cubic centimeters. And lastly, then actually not lastly, almost there, then we'll get to grams, and then we'll get to kilograms. Let's put it all together. So just going from liters to milliliters, that's where our metric system comes back into play. There's no way of avoiding this one. So looking at that, our first conversion factor is using the metric system, 10 to the negative third liters, because that's our base unit, is equal to 1 milliliter. Okay, so now that we got liters, we're now at milliliters, and we want to equal that. So we said what equals it is that 1 milliliter is then equal to 1 cubic centimeter. Still not there. All right. Next, what equals cubic centimeters? Our density. So our third conversion factor will be our density, which is 19.3 grams per every 1 cubic centimeter. Now, it doesn't matter if I actually were to swap these two. So you're able to interchange this, meaning I could have done, this is 1 cubic centimeter is equal to 19.3 grams. Okay, they both mean the same thing. So right there, we're at grams. We're still not where we want to be, right? We're finding kilograms. So our fourth unit, or conversion factor, I'm sorry, would have been 10 to the third grams, going back to the metric system, is equal to 1 kilogram. Okay. Any questions here with our conversion factors? Did I lose anybody? I'm good. No questions. Okay. And then I realize it's getting a little bit later, but I'm going to continue with this question, and then I'm going to move on to answering as many questions as possible. All right. So this will be our last conversion question, but I'll answer more questions after. Okay. So continuing on with this, I'm going to go ahead and actually set this problem up. So with our plan, we said that going from liters to milliliters, that was our first conversion factor. Milliliters to cubic centimeters, that was our second. Then cubic centimeters to grams is our third, and grams to kilograms was our fourth. All right, let me set this up. So starting with our given, as always, 0.82 liters. Now I want to cancel out liters, so that goes on the bottom to milliliters, and I'm going to actually write in what we have. So our first conversion factor was 10 to the negative third liters on the bottom per every 1 milliliter. I then cancel out the liters, and we're at milliliters. Canceling out our milliliters, we'll do 1 milliliter per every 1 cubic centimeter, which was our second conversion factor. Continuing on, next our milliliters cancel and cubic centimeters is on the bottom. And we're at our third conversion factor, which was our density. So 1 cubic centimeter per every 19.3 grams. And one more. Those cancel. We're at grams to every kilogram. So there is 10 to the third grams per every 1 kilogram. And I'll show you. I'm going to write down how to actually write this in your calculator. So how you would do this is I would multiply straight across, right? So multiplying everything on top. You really don't have to multiply the ones. So this is 0.82 times 19.3. Multiply that first. Okay, so let's see what that gives us. That gives us 15.82, 8.826. There we go. All right, so that's on top. And then multiplied by. All right, so I will show you a math trick again. This would have been 10 to the negative third times 10 to the positive third. A lot of times whenever we are multiplying the same bases, meaning those tens, you then can add your exponents. And that would have been 10 to the 0 power. Anything to the 0 power is just 1. Okay, so in that case, we've got our answer. And that would have been 15.826. We do want to round two significant figures to 2 sig figs, actually, because our given was only 2 sig figs. That leading 0 does not count. All right, so going back, I'm going to round. This would have been only 2 sig figs, I said. So this is going to be just rounded up to 16. And that would have been kilograms. Okay. Hope that all made sense. I'm now going to go into answering as many questions as you guys have. So let me give myself some room. Let's see the questions we got. Okay. All right, let's see. I got several votes for, okay, Arabella. So I'm going to answer her question now. You have a test on Monday. Okay. All right. Definitely going to help you out with that. And I actually think I wrote out this question. I did. Awesome. Okay. So this is a little bit different. It's not, I'm not going to be talking about conversion factors or, what was it? Sig figs. So this specifically, since you're looking of absorption of heat. Now, I actually wanted to ask you if you're still here, Arabella. Actually, Arabella, are you here? I don't know if she's still here. But continuing on. So if, pretty sure this is what you're doing. It's called Q equals MCAT. Does that sound familiar? Okay. Arabella, is this what you're talking about with the heat absorbed? Okay. So understanding this, so let me actually just explain what everything is. Q is our heat absorbed. M is our mass, which is measured in grams. Okay. And by the way, heat absorbed tends to either be in joules or in kilojoules. Guys, if I'm answering specific questions right now, if you haven't gotten to this point just yet in your chemistry class, don't worry, you will be getting there. And I will be doing videos on it, of course. So C is known as our specific heat capacity, which its units, and let me actually write that. So C is our specific heat capacity, which the units are joules divided by grams Celsius. And lastly, this is called a delta T. All that is a change in temperature. So we're doing our final temperature minus our initial temperature. And that's measured in Celsius. Okay, so now that we got all of that, I'm going to just start seeing what I actually have in this problem. So looking at going back to our problem, it says calculate the amount of heat. So right then and there, amount of heat, I'm looking for Q. So I still do this, or I still write down what I'm given, what I'm finding. This actually works pretty much all throughout chemistry. So what we're finding is Q, the amount of heat. Next, we have a 45 kilogram sample, which is going to be our mass. So this is our mass, but we will have to convert to grams since that is the proper unit for mass. Next, it's saying of ethanol from 11 degrees Celsius to 19 degrees Celsius. And I actually looked this up and with a specific heat capacity, with 2.46 joules per every gram Celsius. Okay, so I'm going to start actually replacing and just writing everything that we have. I'm going to erase this real quick. Like I said, it's going to be in the replay. And I'll actually put this all together. Okay, so we said our mass, or M, was 45 kilograms. So what you need to start with first is convert your kilograms to grams. And this actually is a little bit of the metric system here. So that is going to absolutely always be our step. Always make sure that all of your units are correct. So mass has to be in grams. I mentioned that already. So I'm going to go ahead and convert that. 45 kilograms just to grams. So that's kilograms on the bottom per every gram on top. We said that the 1 goes with the different unit, which is kilograms, and 10 to the third. Okay, so really that's just being multiplied by 1,000, which I'm going to actually just convert to scientific notation to make life easier. So it would have been 4.5 times 10 to the fourth grams. Okay, moving on. So now I know what my specific heat capacity is. That has to be given to you, by the way. It either has to be given in the question or there might be a table on your exam. Like I said, that's something that you would just have to be given, or you might just only be solving for that. Okay. So C in our case is 2.46 joules per every grams Celsius. And then we'll figure out our change in temperature. So I said that was final minus initial for our temperature. Our final is always what we end with, right? So 19 is our final, minus 11 would be our initial. So our change in temperature is that 19 degrees Celsius minus 11 degrees Celsius, giving us a change in 8 degrees Celsius. So now that we have everything, we just plug in. So going back to that Q equals MCAT, this would have been Q is then equal to our mass, which we just converted, which was the 4.5 times 10 to the fourth grams. Okay, multiplied that by our specific heat, which is the 2.46 joules per every grams Celsius. Next, just multiply that by your change in temperature, which was the 8 degrees Celsius. Something I do want to note, the cool thing about this is our units actually will all cancel out except for the joules. So if you have all the correct units, all of your units will cancel out and give you what you're actually solving for. So in our case, since we're looking for heat, we want our end result to be joules. So look at this, our grams cancel, our Celsius cancel, and we're left with just joules, which is what we wanted. So I'll multiply that out, just multiplying 4.5 times 10 to the fourth times 2.46 times 8. That gives us a heat of 8.856 times 10 to the fifth joules. And of course, sig figs are always important. How I know which one to use is going back to my given, and my given value was that 45 kilograms. So I'm going to round to 2 sig figs. So rounding to 2 sig figs, I'm going to round this up. This would have been 8.9 times 10 to the fifth joules. And that is our heat absorbed. Okay. So I'm done answering that. All right. Let's see. Megan, I think we're okay on, I did unit conversions and addition and subtraction problems. So I think we're good on that. Let's see what else. And you're welcome, Arabella. Let's see. Let me see what else I want to do. Some people are actually giving me their actual questions. All right. Let me see what I can answer, guys. I know that this is a lot of questions. All right. Let's see. Gabby. All right, Gabby. So Gabby asked, could you go over converting between scientific and standard notation? Of course. Let me go over that. So converting between scientific and standard notation, let's say if we started off with something like 0.000382 and we wanted to convert this back to scientific notation. So scientific notation, you always start wherever your decimal is, and we're going to move this back just to where there is a non-zero number. So when it's between two non-zero numbers, that's when you're done. So you only want it to be like, let's say, I'll show you in a second. So if we move this over, this would have been 1, 2, 3, 4. We stopped there. I said I move this over 1, 2, 3, 4. And we would have had 3.82. So we always move the decimal place where we start having at least just one non-zero number. And then this would have been times 10 to the however many zeros I did, which was 4. However, since I moved this over to the right, this would have been -4. How I like to remember this, because I know it can get tricky, you know, is it positive, is it negative? Whenever, so the exponent is always going to be, so the exponent is negative whenever the initial number is less than 1. So if it's less than 1, which in this case it is, the exponent is always going to be negative. So I always look at it as a very, very small number will have 10 to some sort of negative exponent. Rather, our exponent is then positive. Just going to put a plus. Our exponent is positive when it is greater than 1. So 1 and above, that will have a positive exponent. And I'll show that example right now. So let's say if we had, let's see, a very, very large number. Sure, something like this. So if we had this type of question, we look for where our decimal place would have been, and it actually is always at the very, very end where that 5 is in the ones place. And I'm going to move this over. So moving this over 1, 2, 3, 4, I'll place the decimal place there. So it would have been 1.3245 times 10 to the positive fourth, since we start off with a very, very large number. Okay. And let's say if I was now going backwards. So if I was going backwards and I started off with, let's say, 2.53 times 10 to the, let's say, third, if it were a positive exponent, which we have here, you move to the right 3. Okay, so because we're trying to make it a large number, moving this decimal place to the right 3 would have been 1, 2, 3, and I'm going to put a 0 right here where I have that extra space. So our final answer would have been 2,530. All right, so that's how we expand that back to standard notation. I'll do one more with a negative. So let's say if this was 3.84 times 10 to the negative, let's say second, I'm going to now move this decimal place to the left because it's going to have to be a number less than 1. So moving this decimal place 2 to the left, 1, 2, I place a 0 there, and that's where my new decimal place is. So the standard notation would have been 0.0384. All right, Gabby, if you're still here with us, does that make sense? Does that answer your question? I hope so. I'm going to move on. All right, guys, I won't be able to answer absolutely everything. Need to get some sleep now. I'm with you on that, Anne. You're welcome. You're very welcome, guys. I might just have time for maybe one more, guys, or I'll do my best to answer two. It is getting a little bit later. Okay, so let's see what I got. All right, so I got a lot from Diana. Diana, is there a specific question that you want me to answer? I know that you have, and let me actually see. A few of these are a little bit longer. Yeah, they are. Let's see. All right, so I'm gonna actually answer Ruth's question, and then I'm gonna go into one of Diana's, and just because this one is a little bit shorter, Ruth, I'm gonna start answering one of your questions of 6.3 times 10 to the 9th. What is that? Megagrams. Okay. Going to micrograms, I'm assuming. So we're going to, this is just the symbol for micro. It says pretty as I can make it. So for mega, this is actually something that we would have to know, is that our conversion factor, first off, is going to go from megagrams to then grams, then to micrograms. And going from there, what I'm going to do is taking my, taking 6.3 times 10 to the 9th megagrams, I'm then going to get to grams. So we had to know that trick again, where our different unit is the megagram. So that's our 1. And megagrams is actually 10 to the, or mega is 10 to the 6, which I'll place with the base unit, which is grams. And then next, those megagrams would then cancel and grams would be on the bottom here. Micro would be on top. And once again, our different unit would have the 1. Our grams, or our base unit, would have the 10 to the negative 6. And that actually would be it. So our grams would then cancel and we'd have micrograms on top, which is what we're solving for. So we then multiply straight across and divide by 10 to the negative 6, which here, let me show this. So 6.3 times 10 to the 9th times an additional 10 to the 6th divided by 10 to the negative 6. There's actually a math trick again for this that I can show. So since both of these are the same base unit, we can actually add our exponents. So 9 plus 6 giving us that 15. So I'm just going to rewrite that as 6.3 times 10 to the 15th divided by 10 to the negative 6. And that's what we can plug into our calculator. Another way of doing this as well, I think I mentioned this before, is you can, since both of these 10s are the same base unit and they're being divided, you actually subtract your exponents. So this would have been 15 minus a negative 6. So we're actually adding. And that would have been 15 plus 6, giving us 21. So this would have actually have been 6.3 times 10 to 21st. You're always welcome to obviously, plug that into your calculator as well. But that's my little math trick for you. And that would have been micrograms. Okay. All right, guys, at this point, I'm going to just be able to answer one more question. It is getting a bit late here. And let's see which one I answered, Diana. I'm going to start answering one of the tablet ones. All right, let's see what this is, and then we're going to end this. Okay, so let's see. The Empire State Building in New York is 1,250 feet tall. Calculate its height in meters. Oh, this was just actually a lot of questions. Okay. Sure, I guess I'll start with that one. I actually think I did something very similar to this one. That first one. So this one was, this was our given, okay? And then it says calculate its height in meters, sure. So we're finding our meters. So I actually did something very, very similar, but I'll show this one again. Of course, in the replay, you could also see this. And this was actually pretty much almost identical to the one that I had you guys try out. But we'll still move on with this. So finding is our meters. Okay. So this is that one that I mentioned that you could have done. Actually, we all saw that you could have done yards to feet or feet to yards, or my other way, which was feet to inches or inches then to centimeters and centimeters to meters. I'm going to show it the way that I typically do it. The only reason why I say that is because you typically aren't given that 3 feet is equal to 1 yard. That's just what I've seen. So professors tend to want you to actually use the metric system. So looking at our CF just means conversion factor. Our first conversion factor has to equal feet. So that's where 1 foot is then equal to 12 inches. And then we go from feet to feet, then to inches. Next, we'll get to, we need to find something that equals inches. So 1 inch is then equal to 2.54 centimeters. And now we get to inches. So now we're at centimeters. And lastly, we'll use the metric system using 1 centimeter is equal to 10 to the negative second meters. I'll go ahead and set this up. So once again, our plan was going from feet to inches, then inches to centimeters, and lastly to meters. And I'll put all the different conversion factors that we have here. Okay. So once again, 125 feet. You're welcome, Diana. I'll at least continue with this, and then we'll end. All right. So then our feet will then go on the bottom. First conversion factor with 1 foot per every 12 inches, and then going to our centimeters. So 1 inch now to 2.4 centimeters. And lastly, using the metric system, so 1 centimeter per every 10 to the negative second meters. I'm going to multiply pretty much just straight across. So multiplying all of those together. You don't need to divide by 1 since that's going to be the same thing. This would have given us 3.81 times 10 to the second. I left it in scientific notation. You could either leave it like this, since that is 3 significant figures. I knew that was 3 sig figs. No problem, Diana. Yeah, at the moment I can only answer this one, but I hope this definitely helped. That would have been our final answer to meters. As I mentioned, you guys can actually look at the replay after this. So kind of the plan for this is of course, I really want to help you guys out. I get how challenging chemistry can honestly be. I dealt with it myself as a chemistry major, and what I want to, help you guys out with is obviously understanding the concepts and understanding how to do this. And every single Sunday, what I am planning on doing is having pretty much what we just did today, free online tutoring sessions. So definitely look out for that link that I will be sending you. Overall, every single Sunday, I will be having this. Okay. So this time, and as always, if you can't, actually be in the tutoring session, you will be able to see the replay. All right. So thank you everyone for being here. I hope that this helps. Great. Jessica says, I feel better now. You're welcome, Jessica. Happy to help. I hope that you guys feel a lot better now. So just for my knowledge, do you guys mind writing just in the chat real quick? I know it's a little bit late, at least where I'm at. Do you mind writing in the chat just how confident do you guys feel now out of 1 to 10? How do you feel? Just kind of want to gauge how we feel with these topics. From 1 to 10, how confident do you now feel? Just want to see 8 out of 10. Okay, Megan, cool. 8. All right. 7. Okay. Okay. Awesome. So definitely moving closer and closer to 10. That's exactly what I want to see. And I'd say just keep practicing, guys. That's Brianna. That's awesome. Going from 3 to 8. That's a huge jump. That's seriously, I'm so glad. I hope that this helps everyone with their future quizzes or exams. And just know that the more you practice and the more you dedicate your time to this, the more you're going to understand this, as well as the better you're going to do in your exam. I know a lot of you guys are science majors or are pre-med, pre-dental. That's definitely going to help with everything else continuing on from here on out. All right. So thank you once again. Like I said, I'll be sending you guys links and we'll be in contact. All right, guys. So have a great night, whatever time it is, wherever you are. I'll be seeing you guys later on. All right. See you guys.